I believe I have nothing to do with it, but this is quite a cool event. So, if possible, I would like to have a big round of applause to Mariana, Monica, Ivan, who is our VP of AI. So, this is really awesome. And the rationale of this event, by the way, was for us to be able to hire the best folks in the AI scene in Portugal. So please reach out in that regard. We are doing some cool stuff as you've seen. Back to Mehdi. Many thanks for coming. It's really a pleasure. Your work at DeepMind in the last 8 years has been astonishing. We have some questions, but as we discussed, probably let's go off script and ask some challenging ones. Make it fun. What do you think wins in this AI race? Open mind or Google? Open AI.
It depends what the race is, right? I don't think there's one winner, because I don't think there's one race. I think different people have different objectives, assets, goals, and they should probably base their strategies on that. However, I guess you're asking the question because currently everybody's doing the same thing, which is throwing a ton of compute, a ton of data, and then hoping for something to show up that's really incredible. I think probably at the end of it, people will land in places that make sense for them. If you take Google, there is a bit like Meta. There's already a lot of products with billions and billions of users, so you build these models, you plug them in there, and you serve them to the users already. If you take OpenAI, you don't have this, so they're starting from all the way research, and they have to figure out what really is their product, right? So yeah, it's your question is way more complicated than it seems because there are many races.
Indeed. And talking about many races, and in terms of capture of value in the AI world, do you think that the capture of value is going to generate more value? Is the application layer or the foundational models layer?
Yeah, that's the other, I don't know if you want to say billion or trillion dollar question. Every week somebody throws a massive number in there. It used to be 7 trillion, now it's 9 trillion. Everybody wants trillions to be given to them to build stuff. Today, right, NVIDIA is making more than 100% of the profit, which means everybody else, or most of everybody else, is losing a fortune. If you look at like the whole stack, right, like all the way from infra hardware to pre-trained models to the LLMs or the tools that people need to put together to use them, to then the application layer, really all the way at the bottom, picks and shovels, people will always need that, and there's this advantage that NVIDIA has now that they're building on. So probably still a lot of value there. At the pre-trained or post-trained layer of models, they commoditize really quickly, right? Like the moment you have it out there, someone else comes with something similar, and then you have Meta who says the value of this is 0 because I'm going to give it to everybody for free on the open source. Everybody but Snapchat, they put the limit exactly at the number of users that Snapchat has so that those guys can benefit from it. Then the level above, like all the tools, it's really hard to differentiate there, right? Because it's a horizontal, and you can easily be swapped, and it might be built by those who are building the model below. And so then you're left with the applications layer where I believe that's really where you solve a user's problem, and you can benefit from everything that people are building below you. So if you imagine a world in a few years where you have agents that are replacing lots of workflows, and those capture the value at the application layer, which is similar to how cloud is today, right? Like there is a few players who capture a lot of value at the building blocks, right? Like compute, storage, etc. And then there are way more that capture value by building applications. So it's probably going to be at both ends down the road.
Yeah, and I think the cloud analogy is quite in that regard. I was going to ask you if LLMs allows us to get to AGI, But one thing that I still find funny is that no one has a clear definition of AGI, but what AGI is. So, what's your definition of AGI? Because again, we need to define the criteria to be able to understand if we reach that level or not. So, what's your criteria?
Yeah, absolutely, you're right. Different people have different definitions of what AGI is. Some people have moved on to super intelligence. So everybody's trying to find like their new term and get people to join that new religion. So AGI, the way that I'm very biased, having spent all these years at DeepMind, right? Like it was coined by one of the co-founders, and his view is it's algorithms that showcase cognitive abilities that are higher than human on multiple tasks, right? So that's maybe one way to understand what AGI is. Systems that can help humans do a number of cognitive tasks and exhibit superhuman level of cognition on those tasks.
Do you think LLMs, which are in essence stochastic patterns, allows us to achieve AGI?
The way you frame the question seems that you don't think so, right? It's a massive debate, right? Like, is this really intelligence? It spits out, basically what it does is, like all the presentations that you guys saw today, is, as Virgílio said, is a lot of probabilities, right? Basically predicts something, sometimes it's right, sometimes it's not, and hallucinations and all the right stuff that's required, etc. So, yeah, in my view, there's still a lot to do. You see the hallucinations, you see the reasoning, right? Like LLMs don't necessarily reason. They don't know how to do math yet. You do 1 plus 2, they say something random. So, clearly, on some things, it's not intelligent. On others, as you said, it looks like a parrot. So parrots can sometimes look quite smart, right? I believe it's one route, and we need to keep adding things on top of it. There's this massive debate between like the people who believe in reinforcement learning that the path to intelligence is actually RL because that's how the human mind supposedly works, and so that's what's going to let us mimic this and get there. And then there are the others who thought, no, it's actually about scaling this system, and so let's throw more compute, more data, see where we go. And given this has seemed to work for some time, some folks said, yeah, maybe we'll get to that way.
More GPUs, more money to NVIDIA. In your 8 years at DeepMind, DeepMind did excellent things in biology, energy, infrastructure. Of all of that stuff, which one are you the most proud of? There's so many great things happen, right? Like the ability to train computers to seek knowledge, right? Basically, we're teaching computers to do human-type tasks, and so that helped to find new knowledge. And so I think I'm incredibly proud of the few things. One, the fact that science has an incredibly beneficial impact once you invest and you let R&D happen. It's pretty incredible what you can do, right? Like what the founders of DeepMind had in mind was that if you bring some of the world's best people in a place, you give them all the resources that they need, and then let them advance on this mission to get to AGI, well, massive progress will happen. I think the first thing is really the culture, right? Like that there's this proof that if you give smart people who are willing to push the boundaries of things, resources, and let them iterate, then incredible things happen. And then there is, second, is the applications of this, right? Like AI is a horizontal capability that then you have to apply in very vertical fields. Health was one incredible experience where we spent a lot of time doing really fascinating work on building systems that are as good as the best doctors out there without like the 15 plus years of training that doctors have to go through. You mentioned the energy work where you can reduce consumption of energy.
in big systems, which is incredibly important in this climate change era. Yeah, these are some of the things that were incredibly fun.
Talking about talent and for the product folks in the audience, in this new AI world that changed the rules of how we build stuff, and where do you think AI product managers, AI product folks need to spike and get really good at?
Yeah, that question comes a lot as people wonder how the new technologies will change the way that they work. I believe that a lot of it stays a bit the same for PMs. Maybe for engineers, not really, but for PMs, I think we still need to start from the user, understand their pain points, and then work backwards to match that with some technology that can help solve those. And on top of that, you still need to do a lot of the influencing and bringing everybody together, going into the same direction. Perhaps you will get some help to iterate on new ideas, right? Like with these tools where maybe you need a report on the competitive landscape and you could ask an agent to do that for you. It might go reason for some time and then bring it back. You might want to check that it hasn't hallucinated a bunch of things. But overall, a lot of the job will remain the same. You might get some help in some of the tasks that are quite repetitive. For engineers, I guess it's about more pushing the boundaries of what these systems can do and almost like falling in love with these technologies so that you can iterate and try new things and do even more crazy stuff that then you show to whoever is supposed to figure out what to do with it.
Like that. What's your most contrarian view in the current AI scene?
Different people have lots, you hear lots of things, so it's hard to know if there's like one view. But one maybe touching on what we discussed a bit earlier is this, I don't think that you need all these trillions poured into the system to actually do something useful. I think with what we have, it's already quite a candy store for those who want to build things around it. And so I'm pretty convinced that with the current models, even small ones, there is enough work for people to like take those and then figure out what to do with them, build all the go-to-market side of things, help with the change management of getting people used to interacting with these models in their day-to-day. So perhaps that's the contrarian view, I would say, is I don't think that you need all these amounts being thrown at this.
So when it comes to foundational models, I believe that we are converging towards a lack of differentiation. And so this is, well, a two-part question in the sense if you agree with that or not, that there's a lack of differentiation of comparing Claude with GPT-4 as an example. And if that's the end state where foundational models are commoditized, and again, as we were discussing a little bit, the differentiation is on the application layer to be able to build applications a little bit like CPUs are somewhat commoditized, and then what really makes the difference is in the orchestration of all the technologies to build a product like the iPhone, as an example, right? Tell me your thoughts there.
Yes, with this commoditization thing, it is true that similar to all technologies, as they mature, costs go down because more people use them, and we figure out how to squeeze some more savings from the infrastructure side of things. And then everybody's doing pretty much the same thing, right? So it's not surprising that they end up a bit in the same place. They use the same NVIDIA compute, well, maybe GPUs for some, and they use the same folks for data. They have access to almost the same data sets. And then it's about how quick and how well can they scale all of this up. Then many people use the benchmarks. Somebody talked about evals earlier. A lot of people use the benchmark that they care about and then put their model up there as beating that benchmark. So yeah, I think the differentiation will come from what people actually use these things for more than anything else. Some people compare AI or GI to like how humans invented fire. Yeah, some people use fire to heat up their homes, and others to light up their room, and others to cook food, and others to burn stuff, including other humans. So I think I think it will depend on where you apply this and what advantage do you have in the application that you pick. If you take you guys, you already have all these users, you can just light up a lot of this with AI, while somebody who starts from the technology, they have to build all of the learning and things that you guys have done. So, yeah.
Which leads me to a follow-up question, who do you think wins? The incumbents that have the user base or the new startups? Because in the .com era with the internet, we saw that it was the startups that won, right? It feels that with the AI, incumbents are moving quite fast, adopting and surfing the wave. Do you think that incumbents win in AI, or that we're going to see the same thing as we saw in the .com era, where startups and new companies are the winners in this new space?
It really depends on what winning means, right? Like currently the incumbents are spending a fortune using this. I think it will end up as and it's already, you can see the premise of that, as a race between who will move faster in deploying and understanding where to point these tools, right? Some incumbents, as you said, are taking risks and changing completely the way that they work. Other startups are not waiting or worried about that. So ultimately it's going to be a quick, who's going to be faster at deploying this. And given the current regulatory and environments, you can't acquire, big tech cannot acquire, they figured out a way to still acquire, but it's harder to acquire the ones that go quickly, so maybe this time they will be able to go a bit further.
Yeah. Last question on my end, and then we have questions from the audience. There's certainly lots of hype in this new AI world. Do you think that the hype we have is correct, or should we have less hype given the potential of technology, or should we have even more hype given the potential of the technology?
It depends on where you sit, right? Like for me, I'm incredibly happy that there is what you labeled as hype, because it means more investment is going into this field and lots of people are working on these things and improving them. And I tend to believe that this is a natural evolution of the computing space, right? Like we used to write code by encapsulating all the knowledge in it. Think of all these like if-then statements. And now we figured out how to get machines to actually learn from the data and the answers, like what actually they should do. And so, yeah, to me, I think it's massively underhyped. If somebody said, yeah, some pieces of it, right? I think someone said software is eating the world. Because Mark Andreessen said a while back. I think AI is kind of eating software, so it's also eating the world. Now, for some people, the universe is not that far, so. Yeah, no, I generally think that it's part of the impact that science and research have on the way we live and our knowledge, and so I still think that there is a lot of work and focus that should happen here. I just don't think that this is the one way to get to that point. I think we should still explore the various options. Currently it's the exploit mode, right? Like where everybody is trying this thing until the day it will plateau and we'll have to figure things out again.
The next part of discovery. Marianne, do you have questions from the audience? Okay, first question? Here.
Yes. We have some time. Thank you.
Hello. Thank you for the hard questions and thank you for the discussion. And when it comes to superhuman intelligence, which are the risks that you are most afraid of?
Yeah, I think probably, so there are obviously a number of risks, right? One of them is just our understanding of how these things work. Explainability, not necessarily direct, so depending on where you apply it, you might end up in places that you would worry about. So for example, in healthcare, would I want to be diagnosed by an LLM? Probably not, right? Education is the same. I wouldn't want to be taught by an LLM. And so there is this interpretability thing. There's a lot of ethics and responsibility issues, right? Like where, and someone mentioned that in the talks, a lot of these LLMs are trained on a bunch of sources in the web, like Twitter and other forums and social networks, etc., where what's being said there is not necessarily great or correct, right? And so you might end up increasing the negative side of that. Then there is malevolent use, right? Like perhaps some actors might use this to impersonate other people, to try to like hack into things. So these are some of the big risks here that could worry humanity.
Thank you very much.
More questions?
Hi. My question was similar to his, but instead I asked the obligatory question is, what is your PDUM?
Did you say PDUM?
PDUM, probability of doom.
Oh, PDUM. I'm optimistic by nature, so I don't think there is. Again, it's complicated to say what is doom, right? Like what doom you're meaning end of everything, they're probably very small. I'm quite optimistic that, we invented nuclear weapon and we're still here, right? So many things happen. I think there's a lot still to do. So, mine is quite low. I don't know, maybe it's because whenever my mom wanted us to turn off the TV and we didn't, she just unplugged the thing. Maybe we can also do that.
Do you think that the governments can use or influence, for example, polarize the type of answers that intelligence artificial will give to the user? Polarize opinions or to some kind of
Probably not just governments, right? You could, going back to like the malevolent use of these systems, you could definitely train bots and LLMs that might want to spit out a bunch of things that are not necessarily correct, right? And that comes after like all the deep fakes, etc. So if you wanted to, you definitely could do things that are quite dangerous.
One more thing. For example, right now, we searching in Google or Microsoft Bing, we have an option to select which article we want to read and we want to trust. With the AI, it gives you one answer, at least one answer. And we might accept that answer as true, right? We lost the option to choose what to believe.
Yeah, that's very true. And the thing is, if you ask it that same question another time, it might say something again different. So that's a bit problematic. Yeah, there has to be interpretability, and then as was mentioned in the right talk, you want to know where did that come from, right? And so that you can go back and forth. So yes, it can help you do a number of things, like learn about new spaces, open up your mind on areas that are maybe connect or close to the area that you like but that you didn't know about. But it can also spit out a bunch of things that are quite garbage. So think of it as this is still technology in its infancy. I mean, 2+ years ago, nobody was doing anything here, so there's still a lot of steps to go before it's dry and ready for better use. That doesn't mean that we shouldn't be working on it to improve it.
Thank you, Mehdi. Thank you so much. We will continue these conversations right now.